Hey everybody, I hope you're all doing really good. So I have a bit of a mystery here to solve today, and I'd like to bring you along for the ride. This is an iPhone 10 that was sent in because it will not power on. I'm going to read you what it is that the customer says. Hello, my iPhone 10 doesn't boot or charge. I first took it in to have the battery replaced after I replaced the screen. He replaced the screen. The camera stopped working after the shop replaced the battery. After they replaced the camera, the motherboard began to heat up and continued a reboot cycle until it eventually did not turn on anymore. The heat was not coming from the top of the board, but from the mid-right as held. Interesting, maybe we got a NAND short thing. There is no exterior burn damage or discoloration on the main logic board from what can be readily seen, or any damage on the surface level. No blown capacitors or other fried components. All right, this has already given me like done had 3 other people work on it vibes. I believe something along the lines of an inductor was shorted on the first board layer when the shop was checking voltages with their leads and shorted 2 terminals. Oof. I had it inspected, price quoted for a motherboard repair at a different shop, and they observed that the first shop had slightly damaged a terminal at the top of the motherboard near the camera connector, not the camera connector socket itself. The damage is probably less than 0.5 millimeter across, which is like a mile under a stereo microscope. However, I do not believe this is the cause of the thermal event reboot cycle. Is this something you'd be able to check out? I just need to turn it on to recover the 7,000 pictures I had on it. Yeah, I certainly can check it out, and in spite of how like terrifying this sounds, I think we have really good chances of being able to get this up and running. So let's see what we're up against. Here we are looking at this iPhone 10. It looks just like an ordinary iPhone. Not too much to see here, as they really don't change all that much through the years. We've got a nice little crack here across the back. Maybe that's somewhat related somehow. The pin lobe screws are both in it. That makes me very happy. I should probably wait and open it up and look at it first, but everybody else has already connected a charger to this thing, so I'm going to go ahead and connect a charger and see what we get. Tiny little blips here. Just a little blip, 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 blip. I'm thinking we're most likely not dealing with a main short as I would expect. Hey, look at that, it stopped. Ah, how about that? If this phone had just a flat out main short, I would expect that the blips would have been higher and also continued. So we've likely got something else going on with this model. All right, so let's just get this thing opened up and see what we are up against. We have not only 1, but actually 2 pin lobe screws. This one here feels just a little bit stripped out. That's going to be just fine. The phone already has serious signs of being opened. Like, this is coming apart very easy. I'm going to say there's most likely no adhesive at all here. All right, fellers. Let's see what we got going on behind door number 1, shall we? Ooh. Is this a mutilated iPhone? I don't think so. We've got an aftermarket battery that's not mounted down. That's definitely not mounted down. It actually has all of the screws in it, which is a little bit surprising to see. Dun da da da. Da da. And it looks like the battery has already came disconnected with that shield. It's a little bit sticky. I'm going to say that was most likely still connected just now when I was doing my test, although I'm not sure. Let's just go ahead and get that battery out of the way, shall we? All right, it looks like we've had some wiping and things going on down inside the bottom of the housing. This black stuff sort of wipes off with alcohol really easy and leaves that exposed. It's pretty easy to see that there's been some picking going on right here around the battery connector. These components here, they're supposed to be covered in like a rubbery goop. I'm just going to go straight for the DC power supply and see what that'll tell us. There we go. So I have the power supply set on 4 volts and I've got the current set on 3.2 amps, and I'm going to go ahead now and turn the power supply on. Yeah, we're definitely not looking at a main short or a boost short. So not any main power line here is shorted. And I know that because this thing did not immediately jump to drawing a large amount of current. So now I'm going to press the button to boot in 1, 2, 3, boot. All right, we jump instantly to 800 milliamps of current. So that tells us that we have something shorted that's coming to life after the power button is pressed. So I'm going to go ahead and remove the whole screen assembly. On this model, it's really often something that's caused by that front-facing flex cable, which if we looked at it right now with thermal imaging and that was the case, it would be showing up already. So let's kick the screen assembly aside. So now I'm going to do the exact same thing. Power supply is on, set to 4 volts, and now I'm going to press the button to boot in 1, 2, 3. Boot. All right, straight to 800 milliamps. I'm going to hold the power button a little bit longer. And let's turn the power supply off. Yeah, yes. Very interesting for sure. So we've definitely got something that is being shorted after boot prompt. It's not anything related to the screen assembly because it just jumps straight to 800 milliamps even without the screen assembly. We should expect this phone to draw 80 to 100 milliamps and hang while I'm holding down the power button. And after a couple of seconds, then it will go ahead and jump up and begin doing what I call a normal boot sequence. This is definitely not normal. Now, let's just, before I do anything else to this, let's just have a look at it under the microscope. This thing had a description of having been tampered with by multiple shops. And I haven't looked at it with a microscope. Silly me, right? So I'm just going to go ahead and get the rest of these cables out of the way. And I'm not going to fully remove the board yet, because there's a chance it might have something simple going on where it doesn't require the board to be removed. So we'll just unplug everything here and get it out of the way. I am going to go ahead and slip the front-facing camera module out of here and get that out of the way. Okie dokie, let's have a microscopic evaluation here and see what it is that we are up a... Oh, no. Okay, well hopefully... Oh, for the love of all things holy. Is this like long screw damaged all the way through the board? Like really? I'm gonna say, looking down in that screw hole, maybe it's just like only a little bit screwed and not like punctured all the way through the board. This shield that screws on over here, it's supposed to have screws that are this size that hold it down to the board, but conveniently enough, it also comes along with screws that are this size. And once in a while, this will get reassembled with this long screw here in the place of the short screw. And the person who does this will continue cranking it down, and they must be hearing crunching sounds as it happens. It will go all the way through the logic board and actually come up under one of the ICs on the bottom of the board and just, it is really nasty what happens. So I'm hoping that that's not going to be the case. Let's not dwell on that too long because that's kind of tragic, honestly. What else do we got going on here? We've got the overfill picked off of these components here. I'm going to say some probe marks here and here. It looks like possibly some probing going on here. And, ooh, what do we have here? This isn't supposed to be like that now, is it? And maybe this is the damage that was spoken about on the connector. Like this customer said that something was damaged on the connector. That's not, that's not real bad at all. But he also said not the camera connector itself. So this here is an antenna connector. Let's just have a gander under this. And that's not really damaged either. That looks fine. How about along NAND? We don't have anything going on up there. What is this component down here that's all gnarly and broken off? Oh, you know what? That's been tried to solder back on. I see like a blob of solder under that. It looks like somebody maybe used like a Walmart soldering iron or something and tried to solder that back on with a big old full-size, Wagner heat gun or something. Hope they didn't float the board, right? All right, let's just skip everything. Let's just go straight to thermal imaging. That's going to narrow this down right off the bat exactly where this short is. I mean, and maybe the short's gone now that I've disconnected everything else from the board. Maybe, just maybe. Let's have a look at thermal imaging and see what we got. Okay, so I've got the DC power supply hooked up. The thermal imaging is covering the entirety of the motherboard here because I want to see where this thing is blasting off at whenever I press the button to boot. We're going to turn the power supply on, still drawing 0 amps. And now I'm going to push the button to boot. And 1, 2, 3, boot. All right, what have we got here? Nothing? Oh, you know, might just want to keep the power button hooked up. There we go. All right, so I'm going to press the button to boot, and 1, 2, 3, boot. Ooh, we're getting a short on the lower signal board down here. What in the world? Okay, turn the power supply off. What? All right, so we've got a little bit of a sticker in the way down here. And also, you know, oh, is it liquid damaged? Might be a little bit of liquid damage. Let's disconnect this lower antenna flex because that has been connected through the entirety of this. And let's just look at all of this just a little bit closer, shall we? Is that little chip cracked? That would be kind of odd. All right, let's get this goofy little sticker out of the way. Oh. This is folded over here. Wonder if we've got any power connections going on here. All right, get the sticker out of the way and fold that little pin back up. Actually, before I fold that little pin back up, let's see what we do on the DC power supply again. So here's the power supply on the screen. I'm going to turn it on. Okay, 4 volts. It's set to 3.2 amps. And I'm going to push the button to boot in 1, 2, 3. Boot. 120. 200. The short is gone. How do you even charge for stuff like this sometimes? Like, can you see what's going on here? Let's just zoom in and look at this connector a little bit closer. We have something that is bent over right here at the edge of the connector. It's just right there. And I suspect when that cable is pushed down on there, maybe it's pulling something to ground that shouldn't be pulled to ground, or it's the actual antenna flex cable itself. So let's just straighten this out first. Power supply is now off. And what I'm going to do is just try to stand this back up as it should be. It kind of felt a little gnarly, but we'll take it. And then the same thing down here on the bottom side of that. We're just going to go ahead and stand that right on back up as it should be. Now, before I hook this back up to power, I want to see what our possibilities are. All right, so switching over here to Flexboard View. I really love this software. Thank you, Paul Daniels. I'm going to have a look at that connector here. So this is JLAT1_E, and on one side of this we have ground, and then on the other side of this we have ground. Now, so that means that we had ground pins folded over and touching what's likely to be PP1V8_GPO_LAT_E, maybe, but, and then what's next to that? We've got 75_LATUN I have had faulty flex cables in the bottom of these before. So what I'm going to do now, I'm going to just go on ahead and reconnect that flex cable after I have a look at the bottom of it. The bottom of that flex cable actually looks okay. We've got a little bit of disfigurement caused by, it actually has the look of possibly having been melted right there where the short likely was. I'm going to say that this short probably was not down inside this cable, but just plugged on all crazy, like a shop made a really silly mistake. So I'm just going to go ahead and plug this right back on here. And let's just switch directly back over to the DC power supply now that that cable is plugged on there properly. And we're going to turn the power supply on. We're drawing no amps at 4 volts. Let's press the button to boot and 1, 2, 3. 70 milliamps, 120. This is a normal boot sequence. So now that I know where the short was at, you know, I believe they expected it was this connector up here that was damaged, but it was really this connector down here. Like, what in the name of all things holy? All right, so we're just going to go ahead and hook up all this stuff. I'm going to hook up the DC power supply like that. And now I'm going to press the button to boot. And 1, 2, 3, boot. Nothing? What, did it come unplugged? Yes. Okay, and now I'm going to press the button to boot. And 1, 2, 3, boot. We're drawing 70 milliamps, 120. Ready, ready, ready. Apple logo. I wonder just how long this phone has been sitting with this guy wondering if he's going to be able to get his data. So the phone is now, I might have to blur that. Do we have working touch? We do have working touch. This is a phone that I actually do not have the passcode for. I may request it if he wants me to troubleshoot cameras, but he's really just wanting this thing to come up and run for the sake of getting data. So I'm gonna go ahead and turn the phone off. All right, we'll slide the power off. Let's have a look at that component that got all screwed around and knocked to the side. All right, so having a look at this with the microscope, we have got this weird thing going on here. We have this little component here that's been like pushed around, and you can see that somebody has probably, you know, they've struggled with it just a little bit, replacing it. It actually looks like it might be electrically sound. Wait a minute. Let's just see what it is. So switching back over to my beloved flex board view, let's scroll over here and get to the top board, which it's orientated slightly different on the bench, so we can just kind of flip that around here. And that component, it's right in here somewhere. What is that? On the board, we have two components here, one in the middle, and then we've also got one component up and out here to the left-hand side. So what that says to me is that that component, so says the almighty Flex Board View version 5, that's supposed to be a capacitor. And it looks to me like somebody's probably put a resistor there. So looking at this with the microscope, if I touch the third pin over here, and then touch right here, that's definitely the right pin. And then how about the other side? Nothing. So, okay. That may actually be a capacitor that they've installed there. Yeah, that's going to be okay. And a non-event. I mean, it looks like complete, total crap. I'm probably just going to go ahead and replace that because I'm ridiculous. I guess they disconnected this bottom antenna flex cable doing the battery replacement and accidentally folded it over and mangled it up and shorted the board out. There was only that short. I'm going to go ahead and fix this little problem that we have here and just make sure that that capacitor is not going to become shorted, whatever it is. Let's just go ahead and fix this little capacitor problem here while I'm at it. Now, to give you a good idea of the size of the component here that I'm replacing, this is a standard dinner toothpick. This is the sharpest toothpick that money can buy. And that's how big that component is compared to the tip of this toothpick. It's basically nothing. It's a grain of sand. I'm just going to add a little bit of flux to this. Oh yeah, now that I've got some flux on there, I can tell that it's a capacitor. So I'm just going to get in here with my iron and blob this thing off of here. Ow. There we go. That has been deleted, whatever kind of madness they had on there. And I'm going to fluff these pads up with something that I know is going to not give me complete misery trying to install a component. Good enough. So this isn't like a VCC main cap where we just have tons of them all over the board where we can just omit them and move on. Chances are without this cap, this thing would be just completely fine. But this cap, I believe this is intended to smooth out the voltage drop that may occur on the other side of FL 4556. Now, because this board has a very, very low melting alloy that's holding it together, I'm not going to replace this using hot air. I'm going to try to do this without hot air. Now, I know this customer is just wanting this to power up for data access, but if I can also send the phone out fully functional, I will. Oh yeah, baby. All right, so that is nicely soldered in place. Actually, as good as I'm going to solder it. You know, I am just I'm just a little bit jittery today. All right, so that has this thing pretty well cleaned up, spotless. Now I am going to go ahead and tension out this battery connector just a little bit. For those of you that work on these models of phones, you know just how crazy sensitive the battery data pins are. If we don't fix this mess, this phone will only stay on for about 3 minutes and then it's going to restart, and you can't transfer 7,000 pictures in 3 minutes. So if you look very closely, and I mean very closely, at this battery connector, you'll see that it is actually recessed back up inside the plastic, and that is not going to work. This pin here, it's all the way inside this plastic, and this phone will reboot because of that. So the way we fix this is just to get our blade in here and push like this, and we pull that out of the plastic. We don't want to go too far because then the battery connector will smash it down. And then we're going to do this, you know, this one isn't as bad, but we're going to do the same thing to that one. And just stretch that out a little bit just like that. And then as far as this long screw damage that we have going on right here, we're just going to pretend like we didn't see that and move right along. You know, one of the worst parts about these jobs sometimes is just cleaning all the old adhesive out of them. Like, I have to stick this battery back down before I can ship it back out of here. I mean, it seems like a pretty okay battery, but all this old adhesive, you know, it has got to go. So there we have some brand spanking new battery adhesive on here that went down almost perfectly. All right, so I have got this thing all the way reassembled, and I'm ready to see what it does whenever I connect it to a charger. I don't know why I always do this to myself. I really should have tested to make sure this battery was good before fully reassembling it. So here we go. I'm going to connect a charger. We are drawing 160 milli big ones. Off. Oh boy, it's a bad battery. No. Okay, maybe it's going to go to a charging icon. Come on, show me a charging icon. Come on, baby. Charging icon. All right, I'm going to hide the screen a little bit here. Actually, let's put it down here so you don't see their lock screen wallpaper, and that'll save me time having to blur it. All right, now we're getting good charging current. So here's what happened with our charging current. It was sort of just like all over the place. And then once this thing had a little bit of juice put into it, it's straight up to 900 milliamps. And I strongly suspect that the battery percentage versus what the actual voltage is like way out of whack. So this thing's most likely going to be fine after the battery is cycled a couple of times, but boy, that sure did make me nervous, I'll tell you what. All right, we're still hanging on an Apple logo. And now it's off, drawing no charging current. We should get stuck on a battery. There we go, perfect. A battery charging icon. That's what I want to see. So the first boot loop that we've seen there, oh gosh, is because it thought there was enough voltage to boot when there really wasn't. So as soon as the board began to draw some more juice from the battery, it died and then it looped a couple of times. So I'm going to leave this thing sit here and charge for a little while. We are drawing, after that last loop, we are drawing a steady 1 amp of charging current. I'm just going to leave it charged for a little while and let this thing start up. And then once I make sure everything is okay, then I will invoice the customer. So I really have to wonder what the previous tech that worked on this is going to think whenever he watches this video, if he ever finds this video. Somebody has been all over this board trying to figure out where the short was and just like picking stuff off of it and trying to figure out what in the world happened to it while they were working on it. And it was just a connector plugged on sideways. So they're probably going to be both maybe happy to see that, but it may also make them want to be sick to their stomach because this was most likely not a good situation with their customer. So I'll be back in a moment. Okie dokie, this phone is back up and running. We are charged up to 31% battery power and it's drawing a nice stable 1 amp of charging current. I have 2 errors on the lock screen. One of the errors says that there's no SIM card installed. That's actually good because there is no SIM card installed. The other error message says that there is a problem with Face ID, and this is likely because the the front facing camera has been replaced. Now, I'm going to let this battery charge all the way full just to make sure we've got a decent calibration between what the red percentage is versus what the actual battery voltage is. And also, to be absolutely safe, I'm going to offer to this customer to run a backup on this phone before shipping, just in case anything happens before they get it back. You know, I'm absolutely certain that this customer thought that there was a much, much larger problem going on with this phone. In fact, I'm even more certain that the previous technician that was working on this thought for sure that something really horrible had happened. But it actually wound up being a really straightforward repair, and the previous technician is probably going to want to give himself a facepalm after this. And so yeah, there you have it. This is going to be a happy customer. And also, this is going to be the end of this video. So if you like my video, please give me a thumbs up. Also, if you like this type of thing and you want to see more of it, feel free to subscribe. And I will see you in the next one. Have a good day, everybody.